Okay, let's share the screen so we can do this problem. All right. The probability of having a type of cancer in a population is 0.03. A test for the disease is 99% accurate if the person has the disease, and it's 98% accurate if the person does not have the disease. What is the probability of a person having the disease if the test result is positive? The test result indicates that the person actually has the disease. All right, so let's write down the information that we have. So let me highlight this. The probability of having this cancer is 0.03. So I'm going to let C be the event that I have cancer. What other information do we have? A test for the disease is 99% accurate if the person has the disease. So we're 99% accurate if we actually have the disease. So that would be a conditional probability. I am going to let the event P be that I test positive for this disease, for this cancer. So the probability that I test positive, given that I actually have this cancer, is 99%. So the probability that I test positive, given that I actually have the cancer, is 99%. All right, what else do we have? And it's 99% accurate if the person does not have the disease. So it's going to test negative if I don't have the cancer, this particular test. So I'm going to let NC be that I don't have cancer. And I'm going to let N be that I test negative. So the probability that I test negative, given that I don't have the cancer, is the 98%. And the probability that I have the cancer, they told me, is 0.03. There's a 3% chance that I have this cancer. Okay, so I'm going to create myself a little contingency table. And I'm going to have in the columns, I'm going to have that I have the cancer or I don't have the cancer. And I'm going to let the rows be that I test positive or I test negative. Now I do have some information already. I do know the probability of getting this cancer is 0.03. So the total of my cancer column should be 0.03. So if 0.03, 3% of the population has the cancer, 97% does not. So the column sum for no cancer would be 0.97. So now I'm going to go through and I'm going to find the cells. So I'm going to find the I have cancer and I test positive. I'm going to find I have cancer and I test negative. And then I'm going to find the no cancer test positive. I'm going to find the no cancer test negative. And we're going to find the totals. So these cells, let me highlight those briefly. Let's use purple. So these cells here are AND probabilities. So I'm going to use Bayes' theorem to help me find those values for those cells. So let me erase my highlighting. And let's see what we have for Bayes' theorem. Okay, so I have, first of all, they gave me the conditional probability, the probability of testing positive given that I have the cancer. So let's write that using Bayes' theorem. So the probability that I test positive given I have the cancer is the probability that I test positive and I have cancer divided by the probability that I have the cancer. And the probability that I test positive and I have the cancer would be the first cell in this table, first row, first column. And I know all the information except the probability that I test positive and I have the cancer. I know the probability of testing positive given that I actually have the cancer is 0.99. And I know the probability of having this type of cancer, that's 0.03. So I can find the probability that I test positive and I have this cancer by taking the 0.99 and multiplying that by the 0.03. And that is going to be the first cell in my table. And this is 0.0297. So 0.0297. So now I can find the second row, first column, testing negative and having cancer. And the way I can find that is just to take negative and having cancer, take the 0.03 and subtract the 0.0297. Get my eraser. Because that column total has to equal 0.03. So this is going to be 0.0003. All right, now what other information do I have? I have the conditional probability of testing negative given that I actually do not have this cancer. So let's again write Bayes' theorem. So the probability that I test negative given that I don't actually have this cancer is the probability that I test negative and I don't have the cancer divided by the probability that I don't have the cancer. And that's going to give me the cell right here. Let's just put a little line there. It's going to give me that cell right there. So let me erase that. And let's plug in the numbers and find the probability that I test negative and I don't have the cancer. So the conditional probability that I test negative given that I don't have cancer is 0.98. Probability that I test negative and I don't have the cancer divided by the probability that I don't have the cancer. Well, if there's a 3% probability that I do, there's a 97% probability, 0.97, that I don't. So I'm going to take the probability that I test negative and I don't have cancer is going to be the 0.98 times the 0.97. And my calculator says that is 0.9506. 0.9506. So now I can find the cell above because I know that testing positive, no cancer, testing negative, no cancer has to add up to the probability of not having cancer, which is 0.97. So if I take 0.97 and I subtract the 0.9506, I'll get that first row, second column cell. And that's going to be 0.0194. Okay, and now I have all the cells populated, so I can add across to get the row totals. So the positive row would be 0.0297 plus 0.0194. And my handy dandy calculator says that's 0.0491. And then I'm going to add the second row 0.0003 and the 0.9506. And my handy dandy calculator says that is 0.9509. Okay, and what am I looking for? Well, let's go back up and read the problem. What's the probability of a person having the disease, so they have cancer, if the test result is positive? So I actually have the cancer when the test result is positive. So what I'm looking for is the probability that I have cancer given that the test is positive. All right, so from Bayes' theorem, this would be the probability that I have cancer and I test positive divided by the probability that I test positive. And I have that information now that I have the contingency table completed. So the probability that I have cancer and I test positive is that first cell in the table. So it is the 0.0297. And the probability that I test positive is the row total for positive. And that's going to be the 0.0491. So I'm going to divide that by 0.0491. And when I do that division, that should give me the probability that I have the cancer given that I tested positive for it. And that's going to be 0.6049. And some of the information they gave you in this problem is in percentages, and some of it, the probability of having the cancer was given to you as a decimal. So depending on the problem, you might leave that written as a decimal, or you might write that as a percentage. And I hope that's been helpful. Sometimes doing these conditional probability problems, it's very helpful to do a contingency table, because then you get all the and probabilities, and then you can use that to find any other conditional probability that you're looking for.